Indices by default will always be 0, 1, and 2. And similarly, if you want to select multiple columns, you can simply pass the list of the names of the columns that you want to fetch. And any guesses what the structure will be there? Exactly, like easy, right? So easy. So yeah, it will be data frame, and if you want to fetch a row, you can just simply pass the index of the row. We just pass the index of the row to the location value, which is LOC, and it will give you another series. But as you can see, the indices now are changed. Indices will be the column names now, because in this case, when we fetch a row, the data is really X, 6, and true in this case, and the indices will be the names of the column, because those are the identifiers for any value. So now if you want to fetch the multiple rows, what we can do is just do it the Pythonic way. Just mention whichever rows we want, and it will of course fetch the 0th and first row, like this. So that was just like when you know that what you're going to fetch. But what about if you have some conditions, like if you want to fetch some data based on the value in some column, then you can just do this. So in the square brackets, just mention the condition that you have, and easy to guess that it will be a data frame. It will just return those rows which satisfy the condition. And condition can be on any number of columns, as we can see the sort of a complicated example, which is, let's say a hypothetical condition, we want to fetch the rows which have X or Z value in their first column. We can do this. Like, it can be any sort of complicated condition, and it will just fetch according to your condition, in this case this. So let's say we have these two data frames now. As you can see, there are A, B, C, and D indices for the first one, and A, B, and C columns, and the second one, A, B, C, D, E as indices, and A, B as columns. So if we decide to merge these, if we decide to add these, which is like addition operation, not exactly arithmetic, but we'll see how it is not exactly arithmetic. It will return you this. So as you can see, some of the values are sum of corresponding values in both the data frames, but some of them are not defined, which is like not a number, which is none type in NumPy, and which is sort of ported to Pandas because it relies on NumPy. So why are some values not a number? The reason is, for example, for E row, for E index, there's no value in the first data frame, so it doesn't know what value to add, what value to fetch, and that's why it cannot perform a addition operation or a merge operation on E. So that's why all the elements of E in the resultant data frame will be not a number, and the same is the case with the C column as well. So we see a lot of not a number values, right? How can we handle it? Like if we code every day, right? So we know if something goes wrong, either we drop it, either we eliminate the risk, eliminate the bug, or we fix it, right? It's like as simple as that. So let's see how we can handle these missing values. We can either drop them, either we can say, okay, if anything is not a number, we don't want to keep it. Or we can just say that if anything is not a number, we're going to fill it with some value and on the basis of some logic. So let's say the first thing, like if you want to drop the values, you can just pass on the method like drop NA, and by default, it's going to drop all the rows which have at least one not a number value. So which has at least one undefined value, it's going to drop all those rows, as we can see this. And there may be a case when you want to say like, okay, second row, like the index 2 row, has some values, has some data, so we want to keep it because it has some data and we're not going to lose it. For that, we have another method which is like you can pass a parameter saying like how do you want to drop the values. You want to drop the values only if all of the values are undefined. So it will just drop the last row, so it's not going to lose, you're not going to lose any data which you are losing in the first case. And let's talk about another case, like when you fill the values in some manner. So we have this data frame again, And what we can do is we can just pass a default value which we want to, like, this is like one case when you know that if there is something undefined, you want to fill with something like, let's say 0 or -1 or something, which is like the default value for your data. And it will just simply replace every not defined value with that default value that you pass. And if you don't really want to do that, like if you're like, no, why should I fill with 0? Fine. You can use fill NA method with the parameter which is like forward fill. ffill is for forward fill. And what it will do is it will take the value just above the not defined value and copy it all over. So as you can see, in the second row, there was a not defined, like not a number, but now it is 10 because the 10 is copied from the last defined value. And similarly, you have backward fill methods as well, and just like pass the method equal to bfill and should be fine. And yeah, so this was a case when it just copied over everything, right? But there may be a case when you just want to copy once, like, or copy twice, and you know that if something is really wrong, then you want to drop all the rest of the values, but you want to surely want to copy some of the values. So you can define the limit. And since the limit is 1 in this case, you can see one not a number value is still left because, of course, because of this one limit, and it won't copy more than once. Let's talk about indexing now. Like I've talked about indices, like we have 0, 1, 2, or we have ABC, we can have custom indices. Let's talk about a little bit more in detail about that. So for this data frame, we have this index, and we can just fetch the index if we want to like do something with the index. In this case, it's not really going to be useful, but as we can see, we'll see later, it will be really like indices can be anything, and this is a way to access any index of the data frame. So let's say we have this data frame once again, and what we want to do is we want to change the index, and we want to assign some column as index. Like we want to use one column as index, like just like we use in like databases, we define some column as an index, and so that searching is easy and everything is searching and sorting everything easy. So we can do the same thing here. We can just pass the name of the index that we want, and as you can see, the new data frame that we will have that column as an index. So everything you are doing using the index now can be done using these values A, B, C, and D. Let's see how we can do that. So same thing. We want to fetch a row. We can just pass the name of the row, which is now like a character A because it's the content of the index. It's like 0th index in this case, and you will get this. You will get a list. Values are, of course, only 6 and true because A is included in the index now. And yeah, the columns will again become the index, as we saw earlier as well. And you can do this as well. You can just, if you still want to go with the row number, like 0-based index, you can still do the iterator location, which is ilog, and you can use that for doing the indexing, doing the fetching the rows as you were doing earlier. So let's talk about like if you want to have multiple indexes, like multiple level indices. So what I've done in this case is I set the index, and let's see the result first. So what I do is I pass the list of indices, which is 1, 1, 2, 2. So what that means is whatever my current index is, assign 1 and 1 to the first 2 elements in the indices, and 2 and 2 to the other 2s. So that means it will create a multi-level data frame, multi-level indexing the data frame, and 1 is going to be the sort of a parent index for A and B, and 2 is going to be the same for C and D. So once we have this like multi-level hierarchy, let's see how we can perform some of the operations again. Again, we want to fetch 2 rows. Let's say we want to fetch all the rows which are under 1 index. We can simply do this, as we were doing earlier. And it will give us that frame because that's a structure for the data that we want because there are multiple rows. And if you just want to fetch still 1 row, we can still do that, but what we need to do is we need to make sure that we traverse from 1 to A. So we can simply pass a list of all the indices, the sort of hierarchy that we want to pass on, and it will just return list again. We have another thing which is like transposing data, which is really useful when we are operating on like some matrix operations or something. And as you can see in this case, indices were 1, 2, and then the next level was A, B, C, and D. But now we have the same level of hierarchy in the column names. So the column names, now bar and bars become the indices, and now index is not multi-level anymore, and it's just one level, and the column names, column structure is multi-level now. So that was just about like manipulating data and manipulating like rows and fetching rows. That may seem really simple, but it's not that. Like Pandas, it's not like just for that. It's also for all the statistics, all the any statistic operation that you may want. So for example, this describe method, it is just like as it says, describe. So it will return you a lot of useful information about your data, like the statistical information. Like it will tell you like average, minimum, maximum, first quartile, second and third, bunch of things like this. So this is a useful method for finding any information about your data. Like when you're like, okay, just have a glance about your data, like what's there, what's the information in your data. There's another method for finding the covariance between different columns or between different aspects of your data. And there's also this method for finding the correlation easily. And there are a bunch of other methods for finding the rank. Like if you have some value in the column and you want to fetch, if you want to find the rank of that value in the column, we can easily do that, like what exactly the rank of this value for all the values in the column. And you also have this, another method for finding the cumulative sum of all the values in one column. Yeah. Okay, so now comes the most difficult part. That's live demo. Let's hope it works. Yeah. Is it visible at the last line? Yeah. Okay. Cool. So, how many of you are like football fans here? Do we have any football fans? Okay. So the data that I fetched today is the number of goals scored by Messi and Ronaldo in the last 10 years. And we're going to analyze that data and to see how we can make some sense of that data that we have. So I will go ahead and just import the library. And this is a data frame. This is like, I actually construct the data frame from a dictionary. It may be fetched from anywhere, like maybe come from some, fetching the data from some tapping or some database or anywhere. And so once I build the data frame, if I try to print it, what it looks like, you may find it familiar now because that's how it looks like. It looked like in my slides as well. So it has one row, like for each year, it is one row, and it shows the number of goals scored by Messi and Ronaldo for that 1 year. Let's see what we can do. So since we know that if we make the index as year, then we know that we can easily fetch the number of goals scored by any one of the players in that 1 year. So that's why I've created another index, which is the entry column, which is year. And now let's see how we can operate some of the operations to find, like to make more sense of this data and to see which player is better. So if we want to fetch all the goals scored by Messi, all the performance of Messi in the last 10 years, we can simply it's as simple as accessing one column. We can just simply do that. And if we want to find the one row, like if you want to find in 2016, how many goals were scored by each of the players? You can simply do that. Like it's so easy. And if we want to find all the entries when Messi scored less than Ronaldo, you can find all those years. And as we can see, there were only 6 years when Ronaldo scored more. Like not only, but yeah. So this is another useful method which gives you information about your data, and it clearly shows that it's a Python class, a data frame, You can see the entries are in integers, 10 entries, 2017 to 2007 to 16, and data columns are only 2, Messi and not null integer values, and same for Ronaldo, and it also shows like some odd 250 bytes. Like, who cares? Oh, maybe care, but not really. So if we want to find the head, like we want to just see how the data looks, we can simply just pass the head and number of values that we want to fetch, and it will just show you sort of a snapshot of the data frame, how it looks like. And same thing is if you want to see from the tail, you can mention the number of elements that you want to see, and both head and tail, if you don't mention any number of elements that you want to see, they're going to show you 5 elements by default. So this is the method I was talking about. Describe. So it gives you a bunch of statistical parameters, like you can see the count, which is not really that useful in this case. Mean, standard deviation, you can see the minimum, 25 percentile, 50 percentile, 75 percentile, and the max value. So yeah, there are a bunch of other methods which are like finding the covariance between these two players, which is like not really useful in this case, but it may be useful if you're like operating on some data which really needs, in which you really need to find like how, what's the covariance between some variables, or you want to see something like that, and you can really do that. And there's another thing which is like correlation. In this case, the correlation won't be really too much because there are like independent players and they don't play like that player is scoring more and I'm going to score more as well. So there's not going to be much correlation. And we also have this sum. Okay, this one is interesting. So as we can see, Messi has scored more goals than Ronaldo. I'm not saying that, data is saying that. So don't blame me if you are like Ronaldo fan and you're saying no, he's better. So yeah, just that's what data says, and we always go with what data says. Yeah?
But I think Messi has bigger standard everything, so Messi is not that reliable.
Maybe, so yeah. Yeah, I knew that was coming. See, I'm not saying anything, I'm not making a statement here. So yeah, there's a method which is cumulative sum, and this it really allows us to find the number of goals scored by each player at any moment, like at any point of time, at any years. Let's say we want to see like how many goals were scored in 2012, let's say. As you can see, like there were 304 by Messi and 270 by Ronaldo. So it's really easy to like make sense of data. This is of course really a small data set, but you can do whatever you can, like whatever you want. Like you can do operations on big data as well, like not exactly the big data, but yeah, the data that you can hold in your memory, and yeah. And yeah, that's all I have for the demo. And no, okay. Anyway, I'm done. Yeah, thanks. We have some questions. No? Yeah.
So you have column. Is it big? Just be the same for each element?
No. So data type for each of the element can be anything. Like it doesn't have to be same. Yeah, you can mix it, but it's going to be difficult for you if you have to manipulate data. If you want to like put some condition on that, it's really going to be you have to check for each value. Like let's say you have integers and strings, right, in one column. Yeah, you can have that definitely, but when you have the faster data, you have to recheck. Like if you are giving some condition, you have to check the type and then compare. So it's really going to be like difficult for you to make sense of data, to analyze the data. And you can find me on all these social links, and yeah, reach out to me if you have anything to talk about, anything interesting to talk about. So do we have any questions? Yeah?
How big of a data set would I have to have where Pandas
It's a question that how big data should be to use Pandas. It should be more than one element. That's it. That depends on memory, because all the data that it's going to have is going to be in memory. So it just depends on what system you are on, and it's really system dependent. So it is of course, there's going to be complexity thing as well, but that's sort of proportional to what your, how big your data is. Do we have more time? Yeah. Do we have any more questions?
So I guess there's no function for adding a second column, because you have the second index, 1, 1, 2, and then you transform the data frame.
I'm not sure I understand your question.
No, well, the second, right, you have the second index, 1, 1, 2, 2.
Yes.
And then you cut here, and then you transform.
Yes. Yes.
And then you have a second column descriptor.
Yeah.
I guess has no function spread the second column descriptor directly. So add 1, 1 in the.
Oh yeah. I'm not sure about that. Whether we can. So your question is that whether we can add multiple level columns directly without doing the transpose, right? I'm not really sure because the library is really big and I'm not aware of all the functions, all the methods. But I'm not really I'm not really sure. I need to check that and see because the library is really huge and I'm not sure of all the methods. Yeah. Another one. Yeah, you can do that just a similar way as you were doing. For this, you need to go from 1 to A, let's say from 1 to A, and you really need to pass 1 and A, and it's going to see okay, this 1 and A are not different ones, so it's going from A, from 1, then A, and it's going to just return the first column. So it's exactly same as we saw here. Yeah, it's just traversing through hierarchy, just a tree or something, you pass along. Any more questions? Okay, thank you.
Don't forget your